Somewhere in a rainforest, an ant is walking to its own funeral. It doesn't know that. It can't know that. Because the thing deciding where it walks and where it dies isn't the ant, it's a fungus. By the end of this, you'll never look at an ant the same way again. Because the thing deciding where it walks and where it dies, and what it makes the ant do next, should not be possible. Host or hijacker. No one is safe. Its name is Ophiocordyceps unilateralis, the zombie ant fungus. And for once, the word zombie is no exaggeration. It lives in the humid tropics and its target is precise, a carpenter ant. It begins as a microscopic spore drifting through the leaf litter. When one lands on a foraging ant, it doesn't bite or sting. It germinates, pushing a filament through the ant's shell and invading from the inside. For days, the ant looks healthy. It walks the trails. It carries food home. But inside that body, the fungus is multiplying, spreading like an occupying army through the spaces between its organs. And then, one day, the orders change. Here is the question that has haunted scientists for over a century. How does a fungus, a brainless organism with no eyes, no nervous system, no thoughts, convince a living insect to do exactly what the fungus needs? Because what the ant does next is not random. It is choreographed. At a very particular point in the infection, the ant abandons its colony. It leaves the safety of the trail. It climbs up the stem of a plant, up a sapling, always upward, away from the ground where it has spent its entire life. And it doesn't stop at any height. It stops at a specific zone, often around 25 centimeters above the forest floor. High enough, humid enough, the exact microclimate the fungus needs to thrive. Think about that. A creature with a brain the size of a grain of sand is being guided to a precise altitude that benefits not itself, but the thing killing it. So the question stands, if the fungus has no brain, no plan, no eyes to see how high it has climbed, how is it possibly doing this? For a long time, the assumption was simple and obvious. The fungus must be in the brain. It must be sitting in the ant's control center, pulling levers, sending commands. It's the explanation that feels right. It's also, as it turns out, probably wrong. In 2017, a team of researchers did something painstaking. They infected ants, let the fungus take hold, and then sliced the bodies of those ants into thousands of microscopic cross-sections, reconstructing in 3 dimensions exactly where every fungal cell sat inside the host. And what they found rewrote the story. The fungus was everywhere, wrapped around muscles, threaded through the body cavity, packed into the head. But the brain itself? The brain was left strangely intact. The fungal cells avoided it. They surrounded it. They did not, by and large, invade it. Which makes the whole thing so much stranger. Because if the fungus isn't in the brain, then it's controlling the body without controlling the mind. It's not driving the car from the driver's seat, it's reaching in from outside and moving the wheels directly. And that raises a darker possibility, that somewhere inside that ant, the mind may still be present. A passenger, watching. So if not the brain, then what? The answer is chemistry, and biology far more cunning than any puppet string. The fungus doesn't need the brain, because it goes straight to the muscles. Those 3-dimensional reconstructions revealed something extraordinary. The fungal cells form an interconnected network through the ant's body, physically binding around the individual muscle fibers, especially in the jaws and legs. They wrap the machinery of movement and take it offline from the ant's own control. Picture that for a second. Not poison, not a brain swap, a web of living threads tightening around the muscles one fiber at a time until the ant's own legs answer to something else. And the fungus isn't done. It also floods the host with a cocktail of bioactive compounds, molecules that hijack the insect chemically, rewriting how signals fire around its nerves and muscles. The ant's daily rhythm collapses. Its sense of where it is, its instinct to go home, its coordination, all of it rewritten by molecules it never made. The brain may still be shouting orders, but the fungus has seized the wiring downstream. The body stops obeying the ant and starts obeying the fungus. The hijacker hasn't taken the throne. It has taken the army, and that army is about to be sent to do one specific thing. But seizing the army was never the goal. It was the setup. Because everything you've seen so far, the climb, the height, the hijacked muscles, was just the fungus getting the ant into position. What it forces the body to do next is the single most disturbing act in this entire story. And the ant will perform it using the last muscles it has left. Watch. And now we come to the moment the entire infection has been building toward. The ant, steered upward, reaches its final position. And then it does something it would never ever do on its own. Something no healthy ant has done in 50 million years. It bites. It clamps its jaws onto the underside of a leaf or the edge of a twig, and it locks. Scientists call it the death grip. The fungus triggers a violent contraction in those jaw muscles, the very muscles it has been wrapping itself around, and the ant clenches down with such force that the muscle fibers can be permanently damaged. The jaws will not reopen. They cannot. The ant is now anchored to that leaf, hanging in exactly the right spot, fixed in place by its own body. This is the title earned. The fungus didn't just move the ant, it used the ant's own anatomy as a clamp, turning the insect into a living tripod, mounted at the perfect height, in the perfect humidity, pointed in the perfect direction. And then, with the host finally locked into position, the fungus does the one thing it has been waiting all this time to do. It kills it. The death itself is quiet. With the ant fixed in its death grip, the fungus consumes what remains of the host from the inside, converting the soft tissue into fuel. Then, often within a day or two, it begins to grow outward. A single stalk erupts from the back of the dead ant's head, a thin, dark stem pushing up out of the corpse like a flag planted in conquered ground. This is the fruiting body, and it is the entire point of everything that came before. Over the following days it matures, and at its tip it forms a structure that releases spores. Now, remember where the ant was steered. Up off the ground, onto the underside of a leaf, at a height of around 25 centimeters, hanging over the very trails where other ants forage. The fungus rains its spores down onto the forest floor below, directly into the path of the next generation of hosts. Every cruel detail of the journey, the climb, the height, the leaf, the grip, all of it was geometry. The fungus engineered a launch platform out of a living creature so that its children would land exactly where the next victims walk. It would be comforting to call this a freak of nature, a one-off horror buried in a distant jungle. It is not. Ophiocordyceps has been doing this for a very long time. There are fossilized leaves nearly 50 million years old bearing the unmistakable scars of the death grip, ancient ants frozen mid-bite long before our species existed. This is not an accident. It is one of the oldest, most refined hijackings on Earth, and it is not alone. What you've just watched is a single example of a pattern that runs through the entire living world, the line between a host and a hijacker. On this channel, that's the thesis we keep returning to. Every forest, every meadow, every quiet patch of soil is full of organisms that have stopped fighting their victims head-on and instead learned to steer them. To borrow another creature's body, its legs, its instincts, its life, and aim all of it at a goal the victim would never choose. The ant on the leaf isn't a victim of bad luck, it's a vehicle. And once you see that the machinery of control can hide inside something as small and ordinary as a fungus, you start to wonder how much of the natural world is quietly being driven from the inside. But the fungus has one last secret, and it turns this whole story inside out. Because the fungus, for all its precision, has an enemy, and that enemy is another fungus. In many infections, before our zombie ant fungus can mature and release a single spore, a second parasitic fungus arrives and attacks it. It castrates the killer, growing over the very stalk that was meant to spread the spores, sterilizing it before it can reproduce. So the hijacker that conquered the ant can itself be hijacked, hollowed out, and silenced. A parasite of a parasite, riding the corpse of its host. Which leaves us with the most unsettling question of all. If the controller can be controlled, if the thing pulling the strings has strings of its own, then how far up does this go? When you look at any creature moving with purpose through the world, the ant, the fungus on its back, the fungus on that one, where exactly does the puppeteer end? And how would any of them ever know they were being driven? If a brainless fungus can march an ant to a precise spot and lock its jaws shut, then ask yourself what a creature with a strategy could do. Because there is a wasp, a real one, alive right now that doesn't kill a spider. It hijacks it. It turns a living, hunting spider into a zombie architect, forcing it to build a custom shelter for the wasp's young before it dies. We're covering exactly how on this channel next, and I promise you, it is worse than it sounds. So before that leaf-clinging corpse fades from your mind, subscribe and stay with us, because the deeper we go, the harder it gets to tell who's really in control. Host or hijacker? No one is safe.